Arc length and radians. Pi. Before we extend our thinking of central angles and arc measures to arc lengths, it's worth reflecting on the number pi, which will be central to our work. This number was a devastating discovery to Greek mathematicians. In fact, the reason that the Elements was written without relying on numbers was because numbers were considered unreliable to the Greeks after pi was discovered. Until then, Pythagoras and his followers believed that all was number. But when they sought to find the number that is the ratio of the circumference to the diameter of a circle, they found out that there wasn't one. The closer they looked, the more impossible it became to find a number solution to the simple expression of c over d, the circumference divided by the diameter of a circle. Here are a lot of the digits of pi, but it goes on forever, so this is not all of them. Pi is an irrational number, a number that is not the ratio of two integers. So no matter how far you take it, it keeps going without settling down. We are comfortable with irrational numbers now, but the Greeks weren't. Now we know that there are many more irrational numbers than rational numbers. Rational numbers are like islands in a sea of irrational numbers, but we are more familiar with those islands as that's where we grew up. In mathematics, it's best to just leave answers with the symbol pi. In science, engineering, and other fields which need a rational answer and where pi shows up a lot, the value of pi is just estimated with the number of digits necessary for the problem. For most problems, 3.14 is close enough. For others, you might use 3.14159, but you will rarely need more than that. For this course, just leave your answers with the number pi as part of your answer. Arc lengths. The relationship between the circumference of a circle to its diameter is circumference equals pi times diameter. Since d equals 2r, 2 times the radius, this is usually expressed as circumference equals 2 times pi times radius. We know that a full trip around a circle is equal to 360 degrees, so if we know the angle of an arc and the radius, we can determine the length of the arc. In the figure to the left, we know that the measure of arc AB is equal to that of the central angle, 70 degrees. But if we're also told that the radius of the circle is 20 centimeters, we can determine the length of arc AB. The length is how far you'd have to travel along that arc to get from A to B. We could do this by first figuring out the circumference using c equals 2 pi r. So we have 2 times pi times 20 centimeters, which is the radius, equal to 40 pi centimeters. Then we can figure out what fraction of the circumference arc AB is by the ratio of arc AB is to the circumference equals 70 degrees is to 360. So AB over C equals 70 over 360, which equals 0.1944. Since 360 degrees is the entire circumference. So arc AB is 0.1944 times 40 pi centimeters, so that is equal to 7.8 pi centimeters. So 7.8 times around 3.14, giving us about 24 centimeters as our arc length. Alternatively, we could just set this up as a ratio and solve it in one step. Arc length over circumference equals central angle over 360. So you plug in the numbers and you get 7.8 pi centimeters. For any arc, you can find its length by multiplying the circumference of the circle by the angle of arc divided by 360. In this case, the measure of the arc is theta, since it is equal to the central angle. Then, arc length AB over 2 pi r equals theta over 360, therefore, arc length AB equals theta over 360 times 2 pi r. In circle A, the measure of arc CT is 60 degrees and the radius is 8 centimeters. Find the length of arc CT. Alright, so the arc CT length over 2 pi r equals theta over 360 degrees. So we have arc CT equals theta, which is 60 degrees, over 360 times 2 pi r, which is 8 centimeters. So when you do this math, you get that arc CT equals 2.67 pi centimeters.